Professor, Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. We will discuss today the machine learning part 3. Learning outcome. At the end of this session, students will be able to describe what is machine learning. Contents. We will concentrate more on the feature extraction, feature types, feature construction, feature transformation, and everything about the features related with the problem which we are going to solve and how to identify the features. So, all machine learning algorithms use some input data to create outputs. This input data comprise features which are usually in the form of structured columns. So, if data is arranged in tabular form and every column of a table consists of a feature. So, if number of features are more, the number of columns in a table will also be more. So, each column represents the feature of the particular machine learning task. So, features mainly have two goals. One is preparing the proper input data set compatible with the machine learning algorithm requirements. And the second one is improving the performance of machine learning models. So, performance of a machine learning model depends upon the feature selection, feature construction, and feature manipulation. There are different types of features if you look at. So, feature engineering is practicing with different techniques. So, these are the different techniques available for feature selection, feature manipulation, and feature what we can say observations. So, first one is imputation, second is handling outliers, third is binning, fourth is hot encoding, then feature split and scaling. We will see one by one what these different techniques are there. So, imputation is what it does is it finds the missing values of the most common problems you can encounter when you try to prepare your data for machine learning. So, it finds out the missing values. So, the most simple solution to the missing values is to drop the rows or the entire column. But see, this is crude method for dropping whole row or whole column is crude method. That's why imputation is a more preferable option rather than dropping, because it preserves the data size. So, what it does is the best imputation method is to use the medians of all the columns. So, if you find out the median values of the given column, we can replace it with the missing value. Okay. Then next is handling outliers is one of the technique of handling the features. So, if a value has a distance to the average of a column, then it can be assumed as an outlier. That means given in a column, if some value is deviating more from the other values in that column, then we call it as an outlier. So, there are two different statistical methods of handling outliers, and these will detect using standard deviation and percentiles. So, standard deviation is one of the technique to handle the outliers, and percentile is another method. So, then what should be the new value if I use standard deviation, and what should be the new value if I use percentiles? So, practically a value between 2 to 4 times standard deviation seems perfect for all the machine learning applications. So, if some value is much more deviating from the remaining values in that column, then what you do is you find out the standard deviations and multiply with the number between 2 to 4 and replace that deviating value. Then next is a binning. So binning is a process where the original data values are divided into smaller intervals known as bins, and then they are replaced by a general value calculated for that bin. So generally a large set of data is divided into small chunks, and this then is represented by the, say for example, mean of that small chunk instead of representing it by mean of the whole chunk. Okay, so the main motivation of binning is to prevent overfitting. So why the binning process is used? To avoid overfitting. As we know, overfitting and underfitting, these are the two concepts in earlier videos. Question: what would be the disadvantage of binning? Okay, see here, pause the video and answer the question. If you look at the previous question, the disadvantage of binning is it prevents the overfitting, but what it does is it reduces the generalization. The disadvantage of having binning is reduces the generalization. Okay, so next method is one hot encoding. So here we will take one example to see how one hot encoding can be done. So one hot encoding enables to convert categorical data into numerical data without losing any information. Say for example, in the left side we have two columns, user and city. Okay, so user are numbered between 1, 2, 3, and city are also named in front of that user. Say for example, user 1 belongs to Roma. Then in the last one column again, user 1 belongs to Istanbul, user 1 belongs to Roma. So this is what the left table. We want this categorical data, like city is what? Categorical data, and we don't want in a machine learning algorithm this categorical data. And if you want to convert this into numerical data, then how it is done? To the right side if you look at, then see here, so Istanbul and Madrid, these two columns are done, and Roma is not written. So Istanbul is also 0, Madrid is also 0. That means first user belongs to Roma. Second, for example, it in the left side it belongs to Madrid, and that's why in the Madrid column there is a 1, and Istanbul column there is a 0. So this way we can convert categorical data into numerical data by using one hot encoding. Then we have another technique of working with the feature, that is splitting. Splitting allows extracting the utilizable parts of a column into new features that contains string data. So here in the left side, if you look at, very simple example is taken. There are two columns, number 0, 1, 2, 3, 4, and the name of the person is given. So the first name, then middle name, and last name is there. And if you suppose we want to work only on the first name, then we can split the data by the machine learning or the feature engineering. So here if you look at, only first name is extracted out of the complete name. Then last is a scaling. So scaling allows numerical features of the data set to have a certain range. So normalization scales all values in a fixed range between 0 and 1. So scaling means it is converting the given input range into another specified range. So here if you look at the three columns, first is just serial number 0, 1, 2 up to 7. Second is the value and current value, and the third column gives you the normalized value. So based on the values, minimum value that is minus 23, maximum value that is 85. So 85 will have normalized value as 1, and minus 23 has 0 because it is the smallest, and whatever is in between these values are scaled to that particular range, that is 0 to 1. So references, I used Machine Learning by Tom Mitchell, McGraw-Hill Publications, 3rd edition, and another is the Foundations of Machine Learning by Mehrir Mori, MIT Press. Thank you very much.